Hello everyone, my final year project is titled RePlasTile Interlocking Pavers from Recycled Plastics and Composite. The aim of this project is to recycle plastic waste into a useful construction material. RePlasTile is produced using recycled HDPE plastic and fine river sand to create an environmentally friendly interlocking paver. The first step was collecting the raw materials. HDPE plastic bottles were collected as the main recycled material, while fine river sand was used as the filler material. Next, the HDPE bottles were washed thoroughly to remove dirt, labels, and other impurities. The fine river sand was also cleaned to remove unwanted particles. After cleaning, both material was sun-dried for several days to remove moisture. This step is important because water can affect the melting and mixing process. After drying, the HDPE bottles were shattered into smaller pieces. Smaller plastic pieces melt faster and mix more easily with the sand. The river sand was then sieved into two different particle sizes, which were 250 micrometers and 500 micrometers. This was done to study the effect of sand particle size on the properties of the paper. Before producing the samples, an interlocking paver mold was designed. The mold design was based on a fabricated laboratory mold and modified to produce the desired paver shape. The mold was then prepared for the molding process. The shattered HDPE plastic was heated until it melted completely. The melted plastic was then mixed with the sieved sand using two different HDPE to sand ratio, which were 2:1 and 3:1. The mixing process was continued until a uniform composite mixture was obtained. The hot composite mixture was transferred into the mold. Hot pressing was then carried out to compact the material and improve bonding between the plastic and sand particle. After pressing, the samples were allowed to cool before being removed from the mold. A total of 4 samples were produced. Sample 1 used 250 micrometers sand with a 2:1 HDPE to sand ratio. Sample 2 used 250 micrometers sand with a 3:1. Sample 3 used 500 micrometers sand with a 2:1. And sample 4 used 500 micrometers sand with a 3:1. The first performance test conducted was the flexural strength test. This test measured the ability of the paver to resist bending forces before failure. The result shows that sample 1 achieved the highest flexural strength of 4.27 MPa, followed by sample 2 with 3.33 MPa. Sample produced with 500 micrometers sand recorded lower strength values. The second test was the water absorption test. Each sample was weighed before and after immersion in water. The percentage of water absorbed was then calculated. Sample 1 recorded the lowest water absorption value of 2.88%, indicating better resistance to water penetration. In conclusion, RePlasTile was successfully produced using recycled HDPE plastic and fine river sand. Among all samples, the formulation containing 250 micrometers sand and a 2:1 HDPE to sand ratio showed the best performance, with the highest flexural strength and the lowest water absorption. This project demonstrates the potential of recycled plastics and composite as a sustainable alternative material for interlocking pavers while contributing to plastic waste reduction. Thank you for watching.